Hey friends, Vincent here. Welcome to Fearless in Rust, where we keep Rust clean and simple. Let's get into it. Today, we are doing observability the hexagonal way. OpenTelemetry plus Jaeger in RustPulse. The goal is simple. Get real structured traces from HTTP use case repo without polluting the domain with infrastructure. Here's the promise of observability in one sentence. We instrument where the work happens, but we export only at the edge, so the code stays clean and portable. Alright, let's walk the RustPulse code and make that concrete. So first part, the exporter. Here we built OTLP exporter layer that sends spans to Jaeger and keeps all backend export configuration in infrastructure code. Right at the top, you see the hotel stack, OpenTelemetry, OpenTelemetry OTLP, and tracing OpenTelemetry. Tracing config is the boundary. It holds the service name, environment, and the OTLP endpoint. An OTLP endpoint is the network address of an OpenTelemetry collector that receives your telemetry, here tracing spans, using the OpenTelemetry protocol. In its setup, localhost points your app to Jaeger's OTLP receivers, and your backend exports spans to that endpoint. Jaeger stores them and shows them in the UI accessible from localhost and on the port 16686. Then, from env reads the minimum environment variables: hotel service name, default RustPulse backend, hotel exporter OTLP endpoint, if missing tracing is disabled, and RustPulse env, defaults local. Now, init tracing. So init tracing builds the OpenTelemetry layer without forcing the app to always export. If the endpoint is missing or empty, it returns tracing status disabled, so the app can still run normally. And right here, this builds the OpenTelemetry resource attributes, service name and deployment environment. And right here, this is the exporter, OTLP over gRPC using with tonic, pointing to your endpoint. RPC, remote procedure call, lets your code invoke an operation on another service like a normal function call, while the framework handles networking and serialization. gRPC is a modern high-performance RPC system built on HTTP2 with strongly typed messages. And Tonic is the Rust gRPC library we use so the app can export OpenTelemetry data to the OTLP endpoint over gRPC. And here we return tracing status active and an hotel tracing layer you can attach to the subscriber and exporter metadata for a boot log. That's the hexagonal mindset. Infra owns exporting, and the rest of the app just emits tracing events. Now, part 2. Installing the subscriber. Here we assemble the tracing subscriber by combining filters with formatting and with the OpenTelemetry layer, so spans actually get recorded and exported. So init is the composition route for logging tracing layers. Check the environment filter. This is where you decide verbosity without changing code. And now, the important call. It loads tracing config and calls init tracing. Then, the ring. If the hotel layer exists, it's added to the tracing subscriber registry alongside the FMT layer. And this is a nice professional polish. If tracing is active, it emits exactly one exporter initialized log and a minimal startup span. You can see those helpers right here. emit exporter initialize log, and emit started span. Okay, now port 3, HTTP spans at the edge. So here we create one request level span per HTTP call in middleware, capturing method, route, status without mixing HTTP concerns into the call. This is middleware, so it's exactly where it belongs, at the HTTP boundary. And look at the span. A single HTTP request span captures method, route, status code, and set hotel name like getMetrics. Then, after the handler runs, it records the final HTTP status code into the span. So now every inbound request becomes a trace route, or a child trace if you later had propagation. Now, port 4, telemetry service. In this port, we wrap business orchestration in spans and record outcomes, errors, so that traces explain what the app did, not just that a request happened. Now, if we go down, fetch all creates use case telemetry fetch all and records outcome plus error attributes. And right here, same for ingest. Use case telemetry ingest is trace 2. This is the payoff. Your Jaeger trace doesn't just show HTTP happened, it shows HTTP happened, use case happened, outcome error happened with structural tags. And that's the difference between logs and observability. Now, port 5, where to run Jaeger. So this just file provides the local trace backend and UI so you can visualize the exported spans end-to-end during development. A just file is like a lightweight makefile for the just command runner. It defines name tasks such as a just backend or just Jaeger. So you can run common project commands consistently without remembering long CLI invocations. You've got a simple local Jaeger command. It runs Jaeger early one and enables the OTLP collector on port 4317. And the doc for running, it is already written right here. This gives you the environment variables to set and the steps to verify traces in the UI. Okay, now the demo part, end-to-end trace in Jaeger. So first, I'm going to follow the exact local tracing checklist from the docs, like you can see right here. First, I configure the OTLP exporter so the app knows where to send traces. So I just have to verify in the env file these variables. So we have the hotel service name, RustPulse backend, the hotel exporter OTLP endpoint, and optional we have also the RustPulse env equals to local. Okay. So now I'll start Jaeger locally so we have a backend that can receive OTLP spans. So right here, just run just Jaeger. Okay, we can open the browser on Jaeger. UI. Tac. Right here. Okay, next I boot RustPulse. If OTLP is configured, it will attach the OpenTelemetry layer at startup. So just let's open a new terminal and run just backend. This way. Okay, now I'll generate two traces, one success and one intentional error. For the success and for the error, I will use that one with source ID equals not a UID. Okay, finally, I verify the trace shape and inspect error tags in Jaeger. So, service, RustPulse backend, operation get metrics. So let's find traces. And here we have the two traces. So first, we're gonna open the success trace and confirm spans. And so you see here, right here, we can see the use case telemetry fetch all. Right now, let's open the error traces and inspect tags on use case telemetry fetch all. And here you can see the error code, the error type, and the exception message. Okay, now let's wrap up. So, the clean hexagonal observability story is the app emits spans where work happens, HTTP and use cases. Then infra decides whether exporting is enabled with OTLP endpoint. And Jaeger becomes your X-ray without infecting the core with infrastructure concerns. That's how you stay fearless. Clean boundaries, real traces, and a system that's easy to evolve. Thanks for your time. See you over.